Hey there guys, we're going to talk about functions and graphs. In our last video we talked about just equations and functions. The great news is that when we start talking about functions and graphs, we're going to be doing the exact same stuff. We're now just going to take it one step further. For example, when you were doing equations and functions, you were just doing input-output tables that look just like that, where you had your inputs and then you attach that with your outputs. Let me fix that up real fast. There we go. Okay, so you had your inputs and you had your outputs. And so you get your outputs, remember, by plugging in your inputs, meaning plug in 2 for x, see what it gives you. 3 times 2 is 6, minus 2 is 4. So the input of 2 gives you 4. Now, that's what we talked about. The great news with functions and graphs is you're doing that, except now we're adding one extra column. We're going to add our ordered pair column. Okay, so now in our ordered pair column, we're taking our input, which is our x, we're taking our output, which is our y, the x and the y. Well, remember, ordered pairs have x's and y's, so that 2 came over here. That 4 came over here, so we just put them together. So this ordered pair is 2, 4. This ordered pair is 1, 1. This ordered pair is 0, negative 2. So literally the x tells you the x of the coordinate, and the output, which is the y, tells you the y coordinate. Each of these are ordered pairs. And if you remember from chapter 1, I believe it was 1-1c, we learned how to graph in the coordinate plane. We learned that an ordered pair tells you what direction to go in and how far to go. So before I even talk about the other topics real fast, I'm going to give a quick refresher, just to see where these came from on here as well. Let's pretend this line is not here. I'm going to use their graph though, because I like to do this on graph paper on coordinate planes because it's going to make it more precise. All right, so let's see. We got 2, 4 for our first one. So 2, 4, 2 is positive. X measures left and right, as you can see. So positive means go right. So go to the right 2 times, so we're right about there. Positive 4 means go up. So from here, we got to go up 4. So we're going to be right there. So that's going to be positive 2, 4. The next one is 1, 1. We got the 1, by the way, because we plugged in x equals 1 into here. So we got 3 times 1 minus 2. Well, that's 3 minus 2. That's 1. And for the next one, for 0, it's 3 times 0, which is 0, minus 2, which is negative 2. Okay, so 1, 1 is right there. Now, 0, negative 2. 0 means go nowhere left and right, but negative 2 means go down 2. So from the origin, go down 2. So it's going to be right there. Now, for the last one, negative 1, negative 5. Negative 1 means go left, just because it's negative. Negative 5, because y measures up and down, negative means go down. So go left 1, down 5. And so that's going to end there. What you'll notice is anytime you're dealing with a function like this, where we have no exponents, nothing scary, just basic adding, subtracting, multiplying, dividing, stuff like that, that's going to be a linear function almost every single time, because you'll notice these numbers over here, they are going, in this case, they're changing at a constant rate. So notice, as x gets bigger by 1 each time, y gets bigger by the same amount each time, and it's by that number in front of it. So negative 5 goes up 3 to get to negative 2, goes up 3 to get to positive 1, who goes up 3 to get to 4. So that constant change like that makes it a line. It makes it linear. And if that's too, and we'll talk more about that later, I just wanted you to see what I was talking about. So what you'll notice is these 4 dots, these 4 points, they line up in a straight line. And in fact, if you're using graphing paper, it'll be a perfect straight line. So take a ruler or be really careful or use a straight edge and just draw a line that goes through all of them. Your line must have these arrows. If you're going to forget that, tell yourself, must have arrows. We say that because that line keeps going. It keeps going. We just chose negative 1 through positive 2. We could have chosen positive 3. And positive 3 would be if we follow the line somewhere about here. Maybe about right there where my eraser is. Positive 3 would be somewhere about there maybe. Okay? So positive 4 would be somewhere about there. Positive 5, somewhere about there. Just give you an idea. So, but we can't just keep graphing forever. We got to stop somewhere. So to just show that this line keeps going, we got to use the arrows because it does keep going. It's not restricted to just the values we chose. So that's what so when you go to graph these, I just want you to know, graphing linear functions, okay? Linear, we know it's linear because they go in a straight line. And for everything in 7th grade math, pretty much, it's all going to be linear functions. So, but especially now, if you ever find that when you're doing these and you plot these points, if one of these points is not in a straight line, that's a way to tell you that you made a mistake either in calculating it or a mistake in graphing it. For example, if we had a point out here, that point is clearly not in line with the rest of them. So that tells us we either made a mistake in calculating it, what we did in here, or a mistake in graphing it. So go ahead and check. So this is one of those topics to where it forces you to, it doesn't force you, it makes it really easy for you to check your work. Let's say you weren't confident that this equaled -5. So -1 times 3, well, -1 times 3, that's -3. -2, maybe you're thinking maybe that was -1. Maybe you thought that -3 minus 2 is -1. So that means you would have -1, -1, which means you would have been right here. You would have noticed you would have had all those points. You would have had this point here, this point here, this point right here, and then you would have had one there. It would have been like a check mark. It would not have been in a straight line. And so that would have been your indicator. Oh, he's the odd man out. I must have done something wrong with him. And gone back to check. Wait a second. -3 minus 2. Oh, you got to go deeper into the negatives. So -3, go deeper. Oh, that's -5. Okay. So that's supposed to be -5, which is down here. So it's a way to catch your mistakes, a way to help you practice. So that's how to do it. That's how to graph a function. You're going to make an input-output table just like we did in last section, except now you're going to graph that input-output table. That's the only difference. So let's take a quick look at the definitions up here. The solution of an equation. Wait a minute, we defined that in the last section because it still applies. The solution of an equation with two variables consists of two numbers, one for each variable, that make it true. Meaning 2 and 4 combined, we're going to write them as ordered pairs from now on because that's an x and a y. When x is 2 and y is 4, we're going to have a true statement. And if you don't see it real fast, 3x minus 2, y equals that. That's what we had originally. So if you make x into 2, so 3 times 2 instead of x, and you still have the minus 2, so you have the equals y, but instead of y, we're going to put a 4 right there. Let's see if this is true. So 3 times 2 is 6. 6 minus 2 is 4. So we have 4 equals over here. Okay, there's a 4 there. Don't assume it's a 4 just because there's one over there. I want you to check because sometimes they won't be. Look at that. They're the same. 4 equals 4. That is a true statement. Therefore, what you plugged in, 2 and 4, 2 for x and y, 4 for y, that is a solution to this equation. It gave you a true statement. Now, sometimes you'll have a question that'll say, is the point 2 comma, let's choose when we haven't used that, -2 comma, we'll call it -3. Is that a solution to the equation? That's what they might ask you. So is -2 comma -3 a solution to the equation? So what we're going to do is we're going to take the equation and we're going to plug in what they told us to plug in when x is -2. So that means x has become -2 and y goes right here, except we're going to make it -3. So we're going to see if this is true. So 3 times -2, 3 times -2, well that's positive times negative, so that's -6. So that's -6 minus 2. We learned over here, you got to go deeper into the negatives. So -6 minus 2 is -8. Equal sign. Over here we have a -3. So we have negative, go away eraser. We have -3 equals -8. Well, is that a true statement? No. No, that's not a true statement. Because that's not a true statement, that means what we plugged in, those are not solutions to the equation. So no, if the question said which one of these is a solution or is this a solution, you can plug in and check. It's that easy. Also, I want to point out, before, when we plugged in, back when we had 2 comma 4 up here, if you go to 2 comma 4, meaning go over 2, and then go up 4, that point is on the graph. So that's another way to know it's a solution if the point is on the line. If we were to go to -2 comma -3 on the graph, so go left 2, go down 3, that's right there. That point is clearly not on the line. That's another way of knowing it's not a solution. So that's a way to check solutions, okay? So now, what I want you to know is solutions are just what makes it true. Solutions are an ordered pair. When you graph these, you make an input-output table, and then you just make those outputs and inputs together as ordered pairs, and then graph them. Draw a line that goes through them, not to them, through them, and now you've graphed that equation. Let's try a few more examples. Sometimes people get a little confused when they see questions like this. Y equals negative x. So when you go to graph this, we'll talk about how to do it in a second, but let's just go ahead and just follow the method of make an input-output table. Remember, input-output table has an x column, it has the function column, which we know the function is y equals negative x, but in here we'll just kind of write negative x. That will give us the y column, and then we need to have an ordered pair column where we're going to put them together. So I like to choose numbers that are small, easy to calculate, make them numbers that are not going to be a big stress. Excuse my moving that, sorry about that. Pick numbers that aren't going to be hard to calculate. So don't pick giant numbers or numbers that aren't going to be very realistic, okay? And especially numbers that are on your graph. You don't want to choose something that's going to be way down here and not on your graph. All right, so anyways, I like to choose typically -2, -1, 0, 1, and 2. I like to see a minimum of 4 numbers. I'm just picking 5 out of habit. So -2, -1, 0, and 1. So I choose smaller numbers, okay? So now let's go with it. Now it's time to plug them in. When you go to plug it in, now it's time we're about to start thinking about what does it mean. I'm just plugging in negative, but instead of an x, I'm putting a blank parenthesis. We always like to plug in with parentheses. So for this one, we get a -2 in there. -1, 0, 1, 2. Now, times 2 those equals. That says -2. -2. That sounds silly. That's like saying minus -2. Well, we remember when you minus -2, you just add 2. Oh, kind of like it's a positive. So that actually does. That equals +2. And if you don't believe me, let's rewrite y equals -x. X doesn't have a coefficient. Let's give him a coefficient. Remember, when a variable doesn't have a coefficient, it becomes a 1. There's an understood 1 right there. So that's really y equals -1x. So think of that as -1 in front if you need to. -1 times -2, well, 1 times 2 is 2, a negative times a negative is a positive, so it turns out the same thing. So -1 times, if you want to pretend there's a -1 out there, great, so -1 times -1, or just say -1, whatever works for you. That's going to be +1. -0, well, 0 is neutral, he doesn't take sides, so he's still just going to be 0. Now, negative +1, or we think of that as a -1 out here. -1 times 1, well, that's -1. -2 or -1 times 2, because we pretend that's a -1, that's going to be -2. So your outputs are 2, 1, 0, -1, -2, meaning your range is 2, 1, 0, -1, 2. Let's put those together in order pairs real fast. 2, 2, 0, 1, -1, and 2, go away eraser, 2, -2. Okay, so each of those are ordered pairs that we're going to graph. I'm just real fast throwing those on there. And this is a complete input-output table to where you have shown where each of your outputs came from. And you got your ordered pairs. So let's graph them real fast and then we'll be done with this question. So our first one's at -2, 2. That means go left 2, up 2. -2, 2, right there. -1, 1. -1, 1 is right there. Okay, 0, 0. Well, that's the origin. He's right there. 1, -1. Go right 1, down 1. 2, -2. Right there. And take a step back. Make sure that those go in a straight line. These do make a perfectly straight line. So I want you to draw a line that goes through them, not just stopping at them, goes through them, and put little arrows on it to show that you know it keeps going. So that line is the graph of the given function. You have graphed that equation. You have graphed that function. Yes, it is necessary right now to make an input-output table for every graph you're trying to make. This idea of input-output tables, it works for any graphing, for any math. You can make an input-output table always. Yes, in Algebra 1, maybe pre-algebra, you'll learn a little bit about the shortcuts of how to graph linear equations. Remember, this is a linear equation because it made a straight line. there are shortcuts when learning how to graph them. And that is something that you will see in the future, but you won't really truly be able to appreciate and understand what those shortcuts do until you do it with input-output tables. So take the time to organize how you calculate it with an input-output table, and then you'll be ready to go with your graph. Let's try another example. Okay, in this example, we've got a different one, and the instructions are the same. Graph each equation. If you think you got this, hit pause. See if you can do this one. Try it on your own. Press pause, do an input-output table, and then graph it yourself. And just remember, when you graph it, the points need to be in a straight line. Maybe you need help with just the input-output table, so we'll start with that. So x is your first column, the function is your second column, y is your last column, and then, oh, I lied, one more column, x comma y. I was thinking of the last video. So those are your 4 columns. So if you needed help just setting it up, start there. Maybe you need help choosing numbers. I'm going to recommend that you choose numbers that are small and easy to calculate. I was moving that to get it off of our graph. So choose numbers that are small and easy to calculate. So I'm going to choose the same ones I always choose just because I just do it out of routine, but you get to choose, meaning they're independent. -2, -1, 0, 1, 2. Try to put these in ascending order or descending order, whatever you prefer. Just go ahead and get them done. Start with the template. 4 times blank x minus 1. It's the same for all of them because we're going to plug in for that x. Don't forget that. So if you want to write these all at the same time to remind yourself they're all going to be the same format, you just have to go ahead and do it. Okay, so time to plug in. -2, -1. Now, here we plugged in, now it's time to evaluate. You have now plugged in everything. If you thought you needed help up until now, press pause and see if you know what each of these equals and write their number right here and then put them together. See if you can do it first. Practice your negative skills. Alright, so now as long as you got these figured out, let's go through it. 4 times -2, well that's -8. -8 minus 1, that means go deeper. -9 is what that gives you. Okay, and now moving on. 4 times -1, the beginning, well that's -4. -4 minus 1, go deeper, that's -5. Then the next one, 4 times 0 is 0. 0 minus 1, well that's -1. 4 times 1 is 4, minus 1 is 3, so that equals 3. 4 times 2 is 8, 8 minus 1 is 7, so that's 7. Now just throw them all together. -2 comma -9. Now be honest, that really does not take that much time to go ahead and figure out those values and organize yourself. You now know all the points. So now if you try graphing these first on your own, if you're not sure, if you're a little unconfident up until now, but go ahead and try, let's graph these. -2 comma -9, so let's see. -2 means go left 2, -9 means go down 9 times. 1, 2, 3, 4, 5. That one's gonna be off my graph. So I'm gonna ignore that one for now. If you're using your own graph paper, you could go as far as you wanted as long as you have room on the paper. Let's try the next one. -1 comma -5. -1 means go left, -5. 1, 2, 3, 4, 5. Okay, so that one's gonna be at the very bottom. So now let's move on to the next one. 0 comma -1. 0 means go nowhere. -1 means go down 1. Okay, 1 comma 3. Go right 1, up 3. Go away. Stop it, Mr. Eraser. And now it's green. All right. So 1 comma 3 goes right there. Now 2 comma 7. Go over 2, go up 7. That's 2, 3, 4, 5, 6, 7. That's about right there. We can estimate. If you have it, you can see it. Go ahead and estimate. No big deal. So now look at your dots. Take a step back. Make sure that those dots go in a perfect straight line. And if you look and you're using graph paper, they will. They'll go in a perfectly straight line. So draw a line through them. Use a ruler, preferably, because it's going to be more perfect, or just be very careful with your hands. That'll give you really close to what we're looking for. And so what you've now done is you've now graphed this equation. You made an input-output table, you got your points, you plotted your points, and you drew a line that goes through your points. That's what we mean when we say graph equations. The input-output table tells you where your points go, and your point tells you where your line goes. So this was another example. What I want you guys to keep in mind is I want you guys to be thinking about what it took, the overall steps. We chose the x values. Okay, I suggest you choose small, simple ones. Preferably be strategic, ones that are within your graphing area if you're limited on space. Don't choose a million. Plug them in and evaluate, see what y equals. Then you put them together, you have your ordered pairs. Use your fraction skills, your negative skills, your decimal skills, whatever skills you've got to use in here when evaluating. It all works the same. So we needed those skills before we could do this. I hope that this video has given you a chance to be able to understand how to graph equations. In this case, linear equations, linear functions. We know they are linear because they make a straight line when you graph them. Oh, didn't mean to grab it. So now just remember, when you go to graph them, they should be making a straight line. If any of those points are ever not in a straight line, it is not going to be a correct point.